Hi everyone, Mrs. Eldridge here. I just wanted to explain a little bit about this week's lessons. This week for math, we're going to introduce you to how your brain processes math. I want you to understand this year that sometimes algebra doesn't seem easy, but we're going to get through it together because I want you to learn how your brain processes math and that it's okay to make mistakes and that actually mistakes are good for you. I know sometimes if I've ever been driving in the car and I got lost, I remember the way the next time I go in my car that same route because I made a mistake. And so you can learn to embrace that you don't have to be perfect at everything, you just have to try. So when I do my lessons, I'm going to kind of bring you through my virtual classroom, tell you what we're doing for the day. So I'm going to start right there. So basically, these are my office hours if you need me for anything at all, and that is posted in the algebra office hours. I have office hours every single day from 11:50 to 12:50, and on Wednesdays from 1:15 to 2 p.m. So you always go to the office hours meet for that, the my office hours Google Classroom. Okay. Don't go to your individual classroom for that because I want anybody to be able to join. So, one of the things I want you to check out in the Google Classroom, I have my class app. And if you click on it, I have a video on how to use it. And it is something you can download to the home screen of your phone or device. And so can you or your parents or guardian, so that you can quickly access the schedule. Each week, I'll put your schedule on so that you know when you have class or when you are remote, when you have a lesson, etc. Okay, so the class app is the go-to place. If you don't have a device, you can get to the class app right in the Google Classroom. So everybody should have access to it. Okay, so those are a couple of announcements for today. Today's lesson, math is about learning, not performing. So it doesn't matter how fast you go or if you make mistakes along the way. We all learn different ways and we all need to be different in this world to be unique. That's what makes the world go round. Our objective, it is important to understand how your brain thinks about math. Here's my agenda. First, I'm going to give you an opening question, and I'm putting all the questions right here in Edpuzzle so you don't have to fill out a million different things. Each week, my lessons will be set up the same way. You have me teaching you, and you fill everything out in Edpuzzle. I'm going to be showing you a video on brain science. I'm going to talk with you about positive classroom norms. I'm going to do a quick math activity with you to show you how you can exercise your brain. And then we'll do a closure activity. So the first thing I want to talk about is an opening question. Okay, I'm going to zoom in a little bit on this here. Make it a little bit bigger for you. For some reason, I've got a whole bunch of extensions open here. And I'm rusty. I'm not used to taping my lessons, so I hope that this goes pretty smoothly. If you ever have questions about anything, never hesitate to reach out. So here are some questions I want you to think about. People are born with a certain amount of intelligence, and you can't do much to change it. Do you think that's true or false? The brain can grow or shrink like a muscle. Do you think that's true or false? A rat can become smarter if it plays with toys or other rats. True or false? Children can improve their intelligence, but adults cannot. True or false? You better be kind on that one too. Just kidding. We learn more when we make mistakes. Is that true or false? And if you're not a math person, math will never make that much sense to you. Do you think that's true or false? So I think you'll be surprised to find out that a lot of those are true, okay? Because learning about math, just like learning about everything, is having a growth mindset. If you learn anything from me this year, it is that I want you to have a growth mindset. And that means you never stop learning and you never stop wanting to improve yourself. Okay, so that's just a little activity to get you thinking today. And I'd like to right now share with you a video on how your brain works. So I'm going to start playing this. I'm going to zoom in here.
My name is Jo Bowler and I'm a Professor of Mathematics Learning at Stanford University. Welcome to the Week of Inspirational Math that my UCube team and I have designed for you. Most of the days start with a short video from my online course with some really important messages about math learning. And today's first message may be the most important of all. Everyone can do well in math. I hope you really enjoy the week. Here's the first video from the course. You may have been told or led to believe that some people are math people and some aren't, or that math isn't for you. Well, it turns out that's not true. Everyone is born with the innate ability to do well in math, and whether you do well or not comes from the experiences you've had and the beliefs that you hold.
Everyone can do really well in math.
There may be some people, who seem naturally good at math, or just love it when you don't. But that has come about because of experiences they have had. Anyone can get to the highest level of math in school.
There is no such thing as a math person or the idea that some people are math people. Everyone is a math person.
Let's look at the brain evidence. Scientists now know that experiences grow your brain, and the brain is so plastic that it can rewire itself and grow in a really short space of time.
This is how learning works. When you learn something, a synapse fires in your brain. It's like an electric current. And the pathways formed by the synapse are like water in the sand. The more you return to an idea, the stronger the pathway gets. If you don't go back to it, it will wash away. When you learn something, your brain grows, and if you learn it deeply, it grows and stays. So you may think some people are just brainy or smart because they just are, but it all comes from what they've learned. And
you can catch up to them.
When you learn, synapses fire. And this doesn't just happen when you're in a class, it can happen when you read, when you build something, when you have a conversation, when you get an idea, and when you make a mistake. Synapses are firing in your brain every day.
The brain is like a muscle. The more you work the muscle, the more it grows, just like in the gym.
If weightlifters exercise with the same size weights, they wouldn't grow muscles, and they have to keep increasing the weights. It's the same with math. The harder you think, the more you struggle with an idea, the more your brain grows.
Here is some of the evidence that has stunned scientists in recent years and made them realize that everyone's brains can grow and change at any time.
Taxi drivers in London have to learn 20,000 streets and 25,000 landmarks in London before they become qualified. They study for 2 to 4 years, and at the end of that time they take a test which is just simply called the knowledge. When they've finished their training, scientists have found that the hippocampus in their brain is bigger. And the hippocampus is the area of the brain that's specialised in acquiring and using spatial information. When they retire from being a taxi driver, their hippocampus shrinks back down. That's how flexible the brain is.
Scientists took a group of people who could not juggle and split them in half. With one group, they really encouraged them to practice, also showing them some good ways to practice.
Not surprisingly, the group that practiced learned to juggle and the other group didn't. But the practice group also had significant brain changes. They grew the seeing and movement areas of their brains, and they developed more ability.
So the brain is much more plastic than anyone ever thought. In one of the studies, a 6-week training course, when students worked on a task just for a few minutes each day, changed the structure of their brains. And we should think about that. Working on a task for a few minutes per day for 6 weeks can cause your brain to rewire and grow. If that's true, imagine what you can do for your brain over the course of a year in a math lesson.
So just a little bit of info there. And what I want you to take away from that is that you don't want that fixed mindset. You want that growth mindset.
One of the most
Oops. We better get rid of that. We want that growth mindset. You always want to be thinking. You don't want your brain to shrink. You want it to grow. And a lot of times I get the comment, I guess it is, or question from students, when are we going to ever use this math, Mrs. Eldridge? You might not use it in your everyday life, but it helps you think, it pushes your brain to struggle, and it helps your brain to grow so you can think about other things. And it's just good for you. So you might not use it per se in your job, but it helps you think about other things. Just like a bodybuilder might lift weights and they might be good at running, even though they don't want to be at a track meet every day. So it's just an example of how your body uses muscles in different ways. And that's the same thing with thinking and growing your brain in math. So enough about that. I want to talk about positive norms to encourage in math class. So these are some things I want you to think about this year as you go through your lessons. And I know it's hard. You're still growing and you've got a lot of exciting things going on in your life. And so sometimes math isn't the coolest. I get it. Okay. Sometimes I don't think it's the coolest either, but I push myself because I know it's good for me. Number one, everyone can learn math to the highest levels. Number two, mistakes are valuable. Mistakes grow your brain. It's good for you to struggle and make mistakes. Like I said, like when I'm driving and I get lost, I'll remember where to go the next time. Number three, questions are really important. Please don't hesitate to reach out to me. It's very important that you're just not suppressing your questions. If you're really wondering something and you're too embarrassed to ask it in front of somebody else, just ask me. Ask me in an email. Number four, math is about creativity and making sense. Number five, math is about connections and communicating. A lot of times if you talk about math, unfortunately, we're not in that typical education setting, and I just love getting kids in groups and having them talk about what we're learning. You'll remember it longer. So it wouldn't hurt to, I know this sounds kind of crazy, if you're learning something in school and somebody says, hey, what did you do in school today? Don't say nothing. Tell them some details you'll remember. So when it comes to a test or quiz, you're actually studying. When you tell your mom or your dad or your cousin or your uncle or your grandma, tell it to your dog. They'll listen. Tell them the details of what you're learning so that you remember it. Number six, depth is much more important than speed. Top mathematicians such as Laurent Schwartz think slowly and deeply. I like to think slowly about math. If I have to do math fast, I probably couldn't even do 2 + 2. Makes me nervous and I get anxiety. So I love to just take my time, think things through, and come up with a really good answer that's well thought out. Math class is about learning, not performing. It's about how hard you try. It's about pushing through examples. And it's not necessarily rushing through something and getting 100 on each thing. Okay. I've known kids where they had to work really hard for a 75, way harder than somebody worked for 100. And that experience is probably more valuable for that person. It will teach them perseverance through job after job after job in their life. Okay. So today, my lesson is all about just kind of getting you to believe in yourself and getting you to want to use your brain. Okay, so that's half the battle. Even if I'm teaching you something and it doesn't quite click, if you keep working at it, it gets better. Okay, so I'm going to do so I want you to try a thinking activity right now called 4 4s. And you could use a piece of scrap paper at your desk at home or at the table. It doesn't have to be anything you're going to turn anything you can write on. Please recycle. The back of something is fine. So what you're going to do is you're going to write down exactly what I just said, 4 4s, and you can see it on my Jamboard screen here. And then what I would like you to do is I would like you to put these numbers together with operations. What are the math operations? The math operations are add, subtract, multiply, and oops, I'm drawing with my mouse here. It's a little goofy. And divide. Those are the only 4 things you can ever do with numbers. Add them, subtract them, multiply, divide them. So I want you to use those 4 fours and those signs to see how many numbers you can create. Let me go down my Jamboard here. 1 through 10. So I don't know if I can type on this. 1, nope, I guess I can't. I might be able to type in a text box here. I'm new to Jamboard. So on your paper, do 1, 2, let's do a space here. 2, 3, 4, 5. And then we'll go back up to the top here so you can see it. This isn't going to work so well, but nope, that's not going to work at all. Scratch that. I'll keep going down through. 5, 6, 7, 8, 9, 10. So on your paper, write down the numbers 1 through 10, and I can rearrange this. So you're going to take and you're going to write down your 4 fours. You are going to write down your add, your subtract, your multiply, and divide. And I want you to see if you can get any of these numbers for the answer. So can you take and say, all right, 4, and you got to follow order of operations, plus 4 is 8. 8 minus 4 is 4. And so then if I put in, I would have to put it up here, times comes first. Let's see if I can do anything with this. So I'm kind of brainstorming out loud. Can you use all 4 fours in any combination to get the answer? So you don't necessarily have to use every sign. And let's see what happens. I got to follow order of operations. So I got to do multiplication and then addition and subtraction because that comes first left to right. So 16, and this is 20. 20 minus 4 is 16 again because these kind of cancel each other out. So that doesn't give me one of these answers. So what I would have to do is I would have to erase. And I would have to try it again. Let me see if I can do a circle around this to get rid of it. Does that work? No. So I would have to erase. And try again. And I don't want to show you the answers because I want you to think about it. So let's try one more. So let's say I do, turn my pen back on here, 4 divided by 4. So I got to make my divide a little bit bigger. That's 1. 1 times 4 is 4. 4 plus 4 is 8. And now I'm following order of operations because multiplication or division, whichever one comes first, left to right, so I can go right in order. And then division and multiplication come before addition. So this would be 1. 1 times 4 is 4. And then 4 plus 4 is 8. So I would be able to find this answer. Okay, and I would write my work right here next to this box. See how many of these combinations you can find, and I'll have you put it right in the Edpuzzle box, answer box.